This week's focus is step 1 of the STEP strategy, reduce. This video will teach you how to reduce the energy demand for ventilation in winter. There are many different ways to reduce the energy demand for ventilation. Blocking the ventilation grill, as in this image, is of course not one of them. Ventilation is a large part of the energy demand in winter. In an office room with 2 persons and an outside temperature of 5 degrees, this can be almost 50% of the energy demand for heating. Ventilation is by definition the supply of fresh air and the removal of dirty air to and from a room or building. The energy demand for ventilation consists of 2 aspects. The first aspect is the electrical energy necessary to mechanically supply and remove the air to and from the room using a fan. Secondly, energy is necessary to heat up the fresh air to the required indoor temperature. The lower the outdoor temperature, see the snow in the picture, the higher the energy demand to heat up the fresh ventilation air. This brings us to the following question. How can we reduce the energy demand for ventilation without compromising comfort and health? Let us first look at the energy necessary to move the air into the building or pull the air out of the building. The energy demand of moving the air in and out of the building depends on the efficiency of the fan, the length of the ducts, the amount of bends and the speed of the air. A wider duct at the same amount of air is therefore the best option to move air into or out of a building. The cheapest way to reduce the energy demand for moving the air is by using the wind, shown by the open window and door in this Pret-a-Loger summer ventilation scheme. Another cheap method is using the chimney effect caused by temperature differences as shown in red in this image. The second aspect of the energy demand for ventilation is the energy necessary to heat the air. This amount of energy depends on the required air quality inside and the presence of indoor pollutant sources. This brings us to the question of how much air you actually need to ventilate. The Dutch regulations and guidelines state around 25 cubic meters per hour per person, or different values for toilet, bathroom and kitchen ventilation. A CO2 concentration of less than 1200 ppm is also advised to ensure a healthy and generally comfortable indoor air quality. Which ventilation systems do we have that ensure a minimal amount of ventilation and need a small amount of energy moving the air? The simplest system is an operable window. See the schematic drawing on the left image. A more advanced system is the ventilation grill, see right image, which is designed in such a way that there is a maximum amount of ventilation possible at a given wind speed due to the maximum opening of the grill. The actual supply systems mentioned before are given in this image. The air that is supplied to the room must also leave the room, and preferably directly at the source of the pollutants. In the Netherlands, a mechanical exhaust is prescribed in kitchen, bathroom and toilet for dwellings. In the Netherlands, a natural supply and mechanical exhaust system is called System C. A more advanced system is System D. This system controls both the supply and exhaust amount of air and is therefore a balanced system. Another advantage of this system is the possibility of heat recovery. Heat recovery, however, will be discussed next week in the reuse step. Have we now found the ideal ventilation system? The mechanical supply and mechanical exhaust system looks like the ideal system for an office during the day. But is this also true outside office hours when there are no people present? A clear understanding of when, where and how much air is necessary for ventilation is the key to reducing the amount of energy for ventilation. The amount of ventilation depends on the amount of people, the amount of harmful sources and the relative humidity in the room. At this moment, it is possible to measure the amount of people, with movement sensors for example, the CO2 related to the indoor air quality and the relative humidity. Measuring other gases and particulate matters is also possible, but more difficult and expensive. Coupling these sensors to the ventilation control systems ensures the right amount of ventilation at the lowest energy demand for ventilation. Coming back to the Pret-a-Loger house, the Pret-a-Loger house also has a control system for ventilation. But that's not all. This control system can also control the amount of heating depending on the presence of people and their preferences. This video explains how to reduce the energy demand for ventilation in winter. But what about cooling in hot countries? If we consider the energy demand for cooling using air conditioning systems in hot countries, it's equally important to ensure the right amount of ventilation so that the energy demand for moving the air and for cooling the fresh air is minimized.